यस, गुड मॉर्निंग स्टूडेंट्स। देखिए हम बात कर रहे थे मोमेंट ऑफ इनर्शिया के बारे में। यस, वी हैव डिस्कस्ड द मोमेंट ऑफ इनर्शिया ऑफ सम ऑफ द सिस्टम्स लाइक द ट्रायंगुलर लैमिना, like we have discussed for calculated for square lamina and for the rectangular lamina. Now we will discuss for other types of systems like, उससे पहले मैं यहाँ पर दो थ्योरम्स की बात करना चाहूंगा। द फर्स्ट थ्योरम इज that is the parallel axis theorem. यस, देखिए पैरेलल एक्सिस थ्योरम क्या बताती है। पैरेलल एक्सिस थ्योरम ये कहती है कि इफ यू वांट टू कैलकुलेट मोमेंट ऑफ इनर्शिया ऑफ अ बॉडी about an axis parallel to an axis passing through center of mass. Moment of inertia of body about an axis parallel to an axis passing through its center of mass is given as, that is I is equal to ICM plus MD square. What is the meaning of this? Yes, let's suppose this is the body, this is its center of mass, this is the axis passing through center of mass, that is the ICM. And you can see this is the axis which is parallel to this. This is I, and the distance of separation between them is d. The mass of the body is m. Its mass is m. So you can write if the distance of separation between the two axes which are parallel and one of the axes is passing through the center of mass, then the moment of inertia of it will become, that is ICM, I is equal to ICM plus MD square, ICM plus MD square, right? जैसे मैं आपको एग्जांपल भी लेके दिखाना चाहूंगा, like we have discussed for the square lamina everything. If you want to calculate, this is the square lamina, this is the square lamina of length L, and let's suppose its mass is m. Its mass is capital M, and you want to calculate the moment of inertia about an axis. Let's suppose it is passing through this. It is passing through this. This is the axis which is at a distance from center, that is equal to L by 2, L by 4. So we know that the moment of inertia about this axis, that is ICM, and these two are parallel and distance between them is L by 4, so it will become I. So we can say I is equal to the moment of inertia about it is ICM plus m into जितना इसके बीच का डिस्टेंस है, that is L by 4 का होल स्क्वायर. Now what is ICM? M L square by 12 plus M L square by 16. So this is I, moment of inertia about it, right? So this is the thing. Now next is the next theorem is the perpendicular axis theorem. perpendicular axis theorem. देखो परपेंडिकुलर एक्सिस थ्योरम क्या बोलती है. अकॉर्डिंग टू इट, फॉर अ प्लेनर बॉडी moment of inertia about an axis passing through its point and perpendicular to its plane is the sum of moment of inertia of two perpendicular axes passing through same point and lying in the plane. देखो इसका क्या मतलब है. लेट्स सपोज दिस इज द बॉडी and this is the point this is one of the axis is passing through it and this is another axis. Let's suppose this is the axis x, this is the moment of inertia about it ix and about this it is iy, and this is the axis which is perpendicular to the plane of the body. This is the axis passing through the plane of the body. This is IZ. So according to this, the IZ is equal to IX plus IY. This is the relation for the moment of inertia for the perpendicular according to the perpendicular axis theorem. And these are perpendicular. Right? These three are mutually perpendicular. This is the thing, right? Now the next is that is moment of inertia of semicircular ring. If this is a semicircular ring, then first moment of inertia about the axis This is I. Because all the masses is lying at a distance that is r distance from there, so you can directly write ki I is equal to mr square. No. For this it is I. That is the perpendicular. You can directly write ki I is equal to mr square. Now, about some different axes, if I want to calculate. If you want to calculate about that axis, passing through its corner, about the axis passing through its corner, that is I1. So I1 is equal to what? It is passing through its center of mass. I am again discussing it. There are some changes there. First of all, I am discussing about that axis passing through its center and perpendicular to it. Its mass is m, radius is r. What is I? mr square. If I want to calculate about that axis, it is I1. Distance between them is r. So I1 will come out to be, that is I plus mr square, because I is passing through center of mass. We can say this thing. But these two are parallel. I1 we can not calculate by this method. So about this axis it is mr square. If I want to calculate about this axis, about that axis, this is I3. About this axis, the whole mass is lying in the same symmetry method. Symmetry mein, if it is dm into r square, dm into r square, so we can calculate for this just quarter circle one. जो इस क्वार्टर के लिए होगा वही होगा. And for the quarter we can calculate कि यहाँ पर जो distance है वो कुछ और है. Here distance is something else. So we can say this is small m. If I take this is at x distance, if it is at x distance, so I can say it is m into dm into x square, and the distance is changing continuously from 0 to r. And how it is changing, that we have to write, and then we have to integrate that. So we are leaving it. I3 is simply, you can write I is equal to that much, and I1 I am leaving it, and this is this. So you can learn I, mr square. Moment of inertia of semicircular disc. For the disc, if you will calculate, I am calculating about this. This is the center of mass about this. You can calculate like this कि if you go at a y distance and then cut a dy, a ring of width dy, तो फॉर dy it will become that is for di it will become that is जितना उसका मास है dm into उसका रेडियस y है तो dm into y square for that m into r square के अकॉर्डिंग. And if I want to calculate then integrate this. Now what is dm? Total mass is m. So what is dm? And let's suppose its radius is r. So what is dm? Dm is the mass of this ring. That is mass per unit area. Area will become pi r square by 2 into इसका area. That area is its width is dy and its that is pi into r. That is 2 into pi. This cancel out. 2m by r square into y dy. So what is dm? That is 2m by r square into y dy. Into y square. That will come 2m by r square into y dy, right? dm into y square, right? So it will become dm is 2m by r square. And y is varying from 0 to r. 2m by r square is common. Now what is for y? Y is cube बनेगा. That integration is y raised to r 4 by 4. 0 to r. If you will put the limit, it will come out to be directly mr square by 2. So its moment of inertia about this is mr square by 2. Is it right? So about this axis, its I value, that I will come out to be mr square by 2. Moment of inertia of hollow cylinder. If this is the hollow cylinder, having mass m, radius r and length l, about that axis. So about that axis, the moment of inertia will become I. It is directly mr square. If you want to calculate about that axis, I1. So distance between them is r. So I can use कि I1 is equal to ICM plus mr square. ICM कितना है? mr square plus mr square. That is 2mr square. बेसिकली ये चीज ध्यान में रखने वाली है कि जो हमारे पास सिलेंडर है, अगर मैं सिलेंडर की इस एक्सिस के लिए निकाल रहा हूं तो बेसिकली आई कैन कंसीडर कि अगर हम सिलेंडर को प्रेस कर दे तो इट विल बिकम अ रिंग. इट विल बिकम अ रिंग. तो रिंग की जो इस एक्सिस के लिए आया था, द मोमेंट ऑफ इनर्शिया फॉर द होलो सिलेंडर अबाउट दैट एक्सिस रिमेन्स सेम. उसमें कोई चेंजेस नहीं आते, राइट? Next is moment of inertia of solid cylinder. This is the solid cylinder. This is the solid cylinder, so masses are present in it. This is the axis passing through its this. Its distance from the R, its mass is m. About this axis. So we can consider the solid cylinder as a ring, disc. So it is about this is m r square by 2. If you want to calculate about that axis, I1 will come out to be, because it is passing through center of mass. That green axis I have shown, it is passing through the center of mass, and if it is passing through the center of mass, then I can use the parallel axis theorem, and I can say I1 is equal to ICM plus distance square, m into distance is r square. That will become m r square by 2 plus m r, 3 by 2 m r square. So this is the relation for it. Is it clear? That is, you can use for the solid cylinder about the axis passing through its center, you can say, and along its length. Why it is used? Because this relation I am not deriving it, I am directly using it, and you have to learn it. Because about that axis, it will become, if we compress it, it will become a disc of mass m and radius r. Next, moment of inertia of hollow sphere. This is a hollow sphere. For the hollow sphere, you can say the moment of inertia about the axis passing through its center. For the center, the all axes are same. जो भी axis center से pass कर रही है, सबकी सब same है. All these axes are same. If all these axes are same, तो about that moment of inertia are same. And it is directly written as, if its mass is m and its radius is r, so you can directly write I is equal to what? The moment of inertia about this, it will be 2 by 3 m r square. You have to keep this thing in your mind. If it is 2 by 3 m r square about that axis, so if you want to calculate about that axis, I1. So if these two are parallel, so I1 will be written as I plus m r square. What is I? That is m r square 2 by 3 m r square. M r square. That will become 5 by 3 m r square. Next is moment of inertia of solid sphere. If this is the solid sphere, then moment of inertia about this axis Yeah, about this axis I, that is written as 2 by 5 mr square, and about this axis I1, if this distance is r, so I1 is written as I plus mr square. 2 by 5 mr square plus mr square, it will become 7 by 5 mr square. Clear? So these are the moment of inertia for some of the systems that you have to keep in mind whenever solving any problems. Now write down the problem related to it. 4 solid spheres of mass small m each and radius small r are placed at the corners of square made up of thin light rods. Of length L. Calculate moment of inertia of system about an axis passing through center of square and perpendicular to its plane. So we have to calculate the moment of inertia for the given system that now I am drawing. This is a square and the corners पे हमारे पास यहाँ पर एक small m masses रखे हैं spheres. These are the solid spheres. So these are solid spheres. हर किसी का मास कितना है m and radius of each is r and this length of this is L. We have to calculate moment of inertia about an axis passing through its center, this axis, about that axis. देखो how we can calculate about that axis. First, हमारे पास सबसे पहले आप कैलकुलेट करो स्फीयर की हर एक्सिस अपनी एक्सिस के अबाउट, which is 2 by 5 mr square, and then you can calculate. You can see these two axes are parallel. What is the distance between these two? The distance between these two is, that is, this is root 2L. So this is how much distance? L by root 2. L by root 2. The moment of inertia about this is I1 and this is I. So I can write अगर सिर्फ मैं एक ही स्फीयर को कंसीडर करूं, पहले तो एक स्फीयर के कारण क्या आएगा, आई कितना आएगा, 4 टाइम्स आएगा इसके अबाउट. लेकिन एक के कारण लिखो, एक के कारण क्या है, फर्स्ट एक के कारण है I1 प्लस ये उसके सेंटर ऑफ मास से पास कर रहा है, दीज टू आर पैरेलल, तो उसका मास कितना है, m L by root 2 का होल स्क्वायर. Now what is I1? 2 by 5 m square. ml square by 2. This is I. That will become 8 by 5 m square plus plus 2 ml square. This is the relation for this center of moment of inertia about that axis. Is it clear? So this is the relation. Next, a rod of mass m and length L is hinged at point O and making an angle theta on vertical. Calculate moment of inertia of rod about an axis passing about a vertical axis. This is the system given. And rotating about it with omega. This having mass m, length L. And this angle is theta. We have to calculate the moment of inertia of this rod about the axis that is shown in figure. देखो, it is not that axis कि इसके लिए हम डायरेक्ट लिख सके ml square by 3. For that axis you have to do one thing. You have to do that. Let's suppose you are moving small l distance and you are taking dm. You have cut dl and its distance from there is this. This is r. So first of all, you can write r is equal to L sin theta. Now what is dm? Dm is, that is m by L into length dl. Now what is the di? Moment of inertia of this dm about that axis. About that axis it will become dm into distance r square. Integrate this. Now what is dm? M by L into dl into r square. What is r square? That is L square sin square theta. Where L is varying from 0 to L is equal to capital. Now theta remains same. M by L into sin square theta. And integration of L square is L cube by 3. If we put the limit, that will become L cube by 3. This will be cancelled out. That will come out to be ml square by 3 sin square theta. That will come out to be ml square by 3 sin square theta. So it is the moment of inertia about that axis. Is it clear? So it will come out to about that axis is ml square by 3 sin square theta. Next is write on the next question. A truncated uniform disk of mass capital M and radius capital R. A small disk of mass of radius r by 2 is cut from it as shown. Calculate the moment of inertia of remaining system about an axis passing through center of original disk and perpendicular to plane. This is the disk. And this system is cut from there. The remaining system is this much. This is the remaining system. So we have to calculate the moment of inertia about that. This is a system of which the moment of inertia we have to calculate it about the marked system या marked axis. इसके बाद हमको calculate करना है. देखो पूरी रिंग का मास कितना था, पूरी डिस्क का m, रेडियस r. तो जो हमारे पास पूरी अगर होती इसके मास को मान लो m1, और अगर ये अंदर वाला सिस्टम भी होता तो मान लो m2 एक मिनट के लिए, अगर ये भी होता तो टोटल जो मोमेंट ऑफ इनर्शिया बनता अबाउट दिस एक्सिस, इट इज ड्यू टू m1 प्लस ड्यू टू m2. हमको m1 के कारण निकालना है, ये टर्म निकालनी है, ये टर्म निकालनी है हमको. तो मैं क्या कह सकता हूँ, जो टोटल का पहले तो टोटल का इसके बाद कितना होगा, टोटल मास m है, m r स्क्वायर बाय 2, मोमेंट ऑफ इनर्शिया ऑफ m1 प्लस मोमेंट ऑफ इनर्शिया ऑफ m2 कितना होगा इसके बाद. m2 का निकालना है तो m2 का पहले अपनी एक्सिस के बाद निकाल लो. m2 का मास कितना होगा, m2 का मास निकाल लेंगे तो m2 का अपनी एक्सिस के बाद कितना है, m2 इंटू बाई 2 इंटू उसका r इज r बाई 2 का होल स्क्वायर, r स्क्वायर बाई 4 प्लस इनके बीच का पैरेलल इज दिस m2 इंटू r बाई 2 का होल स्क्वायर, r स्क्वायर बाई 4. दिस इज ऑफ m2. दिस विल बिकम im1. दिस विल बिकम m2 इंटू r स्क्वायर बाई 8 प्लस m2 इंटू r स्क्वायर बाई 4. दैट विल बिकम 3 m2 into r square by 8 plus m2 into r square by 4. That will be 2m2 r square by 8. That will become 3m2 r square by 8. That is m r square by 2. Now what is m2? m2 is the area of this. So it is mass per unit area. And what is the area of that? Pi into r by 2 का whole square, r square by 4. That is m by 4. If we put the value, that is m2 is m r by 4. If it is m by 4, so you can solve it to calculate the value of moment of inertia for m1 using this thing. Is it clear? Next is 3 rods of mass m and length L are aligned to form an equilateral triangle. calculate moment of inertia of system about an axis perpendicular to its corner, passing through its corner, and parallel to one of side. This is the problem. This is the equilateral triangle, 3 rods of length of mass m. We have to calculate moment of inertia about an axis which is passing through this corner and parallel to one of the side. Right? It is inclined at how much angle? This angle is 60 degree. This angle is 30. So these two rods are inclined at the angle of, if we given the name to these 3, this is 1, this is second rod, and this is third rod. So the first rod is directly at a distance that is L from there. This distance is how much? ये distance आप directly निकाल सकते हो. This, how much is this distance? This is L by 2. This is 60 degree. तो this will become what? अगर मैं इस पॉइंट को A ले लूं, इस पॉइंट को B ले लूं, तो 1060 is AB by divided by L by 2. 1060 is what? That is root 3. 1030 is this. That is AB by L by 2. So what is AB? That is root 3 L by 2. Right? So what is the moment of inertia about this? I. That is the distance, is you can say, that is each rod m into root 3 L by 2 plus इनसे यहाँ पे एंगल पे, and we have derived still in the problem, that is it will become ml square by 3 if it has angle theta, that is sin square 30, and दो रोड्स हैं तो 2 से इसको क्या कर दो, मल्टीप्लाई. Right? So it will become how much? That is 3 by 4 ml square plus sin 30 is root 3 by 2, that will become 3 by 4. 3 by 4, 3 से 3 cutting होगा, and that will 2 से 2 ml square by 2. That is 5 by 4 ml square. Right? So this is the answer for it. Is it clear to all of you? That type of problem is also asked, and this is a good problem, so you can solve it and you can do it. Is it clear? लिखो इसको.